So this is lesson 7.4, solving exponential equations using logarithms. So what we're going to do is use the mortgage equation to solve for a certain value. So for example, Yvonne has a balance of $3,215 in her savings account. So that's always your principal amount. And they're telling us that we have 2.4% interest per year quarterly. So our I value is going to be taking this number and dividing it by 100 first. So you're going to have 0.024. And then you always have to divide it by what your compounding is. So your compounding is quarterly, so you have to divide by 4. Once you divide by 4, you'll calculate that value as 0.024 divided by 4 is 0.0006. Okay, so that is your I value. So when we put in our equation, we know that we're going to reach eventually $5,000. That's what we want to find, is how long it will take to reach $5,000. So 5,000 will replace A. Your principal is what you started with. And then we have 1 plus our I, which is 0.006 now, to the power of n. So this is what we're trying to solve for. We're trying to solve for the quarterly value of n. So first we're going to bring the 3,215 to the other side by division. Okay, so you should get this 1.555 number. And we can add what's in the brackets by going 1 plus 0.006, which is 1.006 to the power of n. Next step is, if we want to solve by logarithms, we're going to use this method by putting a log on both sides. So what you do to one side of the equation, you do to the other by putting a log on both sides of the equation. Our next is we're going to use the power law. The power law states that we can bring that exponent of n, which is a variable, to the front as a coefficient. So that's just going to move spots. So instead of it being to the power of n, it's going to be n multiplied by log of 1.006. And lastly, to solve for n, you just have to divide both sides by log 1.006. What you do to one side, do to the other. So what that does is it crosses it off, leaving us with n by itself. So in your calculator, you're going to have to put what log 1.555 is divided by log 1.006. Close that, and you should get that it is 73.8 quarterly periods, which we're going to round up to 74 quarterly periods. Okay, so that's our answer, 74. So for the next two examples, we're going to solve for the variables of x. So for example number 1, we're going to start just like in the previous case by putting a log on both sides. Then we're going to bring the variable in front. So this is the power law. We're just bringing that x minus 1 down in front of log 3. And then we want to, in this case, divide both sides by log 3, because our goal is to always isolate for the variable of x. And then we can put log 20 divided by log 3 in our calculator. And you should get that x minus 1 is 2.73 if you round to the nearest hundredth. And then we're just going to add 1 to both sides to get x by itself. So when you add 1 to that, you get 3 point, it says to 3 decimals. So I'm going to actually go back here and keep this decimal place as 727. So then it's going to be 3.727 because it wants it to 3 decimal places. Our next example, same idea, put a log on both sides. Then we're going to bring that x plus 2 in front as a coefficient. And then we're going to divide both sides by log 5. So we have x plus 2 is equal to log 104 in our calculators divided by log 5. You should get 2.886. And finally, we want to subtract 2 to get x by itself. So x is equal to, if you subtract 2, 0.886 as our final answer. Example number 2, they're giving us an equation. A0 represents how much of this radion 222 do you have? What do you start with? And then we know it's half-life, so this amount is going down, so that's why the base is 1/2. The time it's going to take for it to reach a certain value, and then your h is the half-life amount. So they want us to actually figure out the half-life amount algebraically using logarithms, so we're actually solving for h. H is what we do not know in this question. So we're going to start with, they tell us that we've received 500 grams of this shipment. So we're going to have initially 500 grams, and eventually it's going to reach this 13.417 amount. So it's going to end up being 13.417 because it's going down in value. It's decaying. It's losing its radioactivity. Then we have 1/2 to the power of our t over h. So t, it's telling us that it is going to take 19 days right here. So 19 days over h. Step 1, we're going to divide both sides by 500. Those are gone, leaving us with 1/2 on the right side to the power of 19 over h. And then 13.417 divided by 500, 0.026834. And we can change the 1/2 to be 0.5 if you want to. Same idea. Now we're going to put log on both sides of the equation. What we do to one side, do to the other. Now we can bring this power in front. The left side stays the same. Okay, and then we want to divide both sides by log of 0.5. So once we divide the left side and put that into our calculator, we should find that it is 5.21979, which is equal to 19 over h now. Now we need to get h by itself by moving it to the other side of the equation, so we're going to multiply both sides by h. So that's going to cross it off on the right side. And then to get h by itself, we still have to divide this 5.21979 to the other side with the 19. Okay, so that's how we'll solve for h, by putting 19 divided by 5.21979 in our calculator, and we'll get approximately 3.64. Okay, so you can always verify. You can always, with your graphing calculator, go y1 into your calculator and y2. The left side of your equation should be y1, the right side should be y2, and you want to find the intersection, and if you do it properly, you should find that the intersection occurs when x is equal to 3.64, as we can see right here. So we can round that up to 4 days, approximately 4 days for this to occur. Example number 3, we have to solve this. So these ones are a little bit more work. The reason being is that the exponent, there's exponents on both sides of the equation. So in example number 3, you can see that we have 2 to the power of x minus 1 equals 3 to the power of x plus 1. So what we want to do is, just like in the previous question, we want to put log on both sides first. Then we want to bring that power in front in brackets. So the x plus 1 and the x minus 1 go in front of the log 2 and then the log 3 here. So that's the power moving as a coefficient in front. Next, you want to distribute. So this is different than the previous examples because we have an x on both sides. So we actually have to distribute that x minus 1 into that log 2 and the x plus 1 into the log 3. So it's going to look like this. X is multiplying by log 2 and minus 1 is multiplying by log 2. X is multiplying by log 3 and positive 1 is multiplying by log 3. Our next step, we want to bring x's to one side of the equation and anything that doesn't have the variable x to the other side of the equation. So this will stay the same, but when we move over x log 3, it becomes minus x log 3 because the signs change when you bring things over across the equal sign. Now we're going to bring the minus 1 log 2 to the other side, and it becomes just positive 1 log 2 plus 1 log 3. So that was already there. Okay, so what I did was I moved this over to the left side, and I moved that negative 1 log 2 to the right side. So they kind of switch spots as long as you switch the signs with them. So now you want to factor out the x, and so what it does is it takes away the x from both of them. So it looks like that. So it's factoring out the x, and then the right side can stay the same. You don't have to write the ones, so that's just extra writing. So I'm just going to remove the ones in front because multiplying by 1 does not change the answers. And then you want to divide both sides by what's with the x to get x by itself in brackets. So this is in brackets, dividing by the log 2 minus log 3 in brackets. Those cross off. And now you just want to calculate that x. If you put that properly in your calculator, you're going to get negative 4.419. Now, to make sure you're doing this properly, I sometimes suggest that you calculate the top and then the bottom separately, and then you divide their answers. So you want to get negative 4.419. So that's 3 decimal places. In your next example, similar idea. The only thing is that the only change that you want to do here is you want to make sure that you have a single base on each side. You don't want to have them both being on the same side. So you want to move that negative 7x plus 1 to the other side, and that becomes then positive 7 to the power of x plus 1. So only the bases change signs, the coefficient in front. So you separate the bases. Then I'm going to put log on both sides, just like the previous case. And then I'm going to bring those powers in front as coefficients. Now I'm distributing x log 5 minus 2 log 5 equals x log 7 plus 1 log 7. X is on one side, so that goes on that side, and the negative 2 log 5 goes on the other side, so they switch their spots essentially. Okay, so as you can see, the positive x became negative x when it moved, and the negative 2 log 5 became positive 2 log 5. So just watch that. Then you want to factor out the x, leaving us with log 5 minus log 7 equaling 2 log 5 plus 1. We don't have to write, so we can just write log 7. And lastly, we're going to divide both sides by this log 5 minus log 7. What we do to one side, do to the other. Now, if you're doing it in one step, you do need to make sure there's brackets on the top level, bottom level, And then if you're doing it properly, you should get that it's negative 15.350. So that's the answer that would give you what you'd get from that. Okay, so just make sure you're putting that into your calculator properly. And that is it for our 7.4 lesson. Thank you guys for tuning in. And